let's start. Have fun.
Uh, Today we talk in semi-simple algebras. All algebras in this assessment are associative, and an ideal, a right ideal I of an algebra A is called minimal if it contains no non-zero ideals, respectively right ideals of the algebra A. Problem one. Let A in big A, let I be a right ideal of the algebra A, and define annihilator AI equal to I in I, such that I and product of A and I equal to 0, shows that N AI is a right ideal of the algebra A. Solution. Uh, I is a right ideal of A, hence I times A subset of I. We need to show that n n AI times I subset of n AI. We take x in n and y in A, so x times y equal x times y in n times I. Then we know that x in A and A times x equal to 0 because x in A annihilator
X
annihilator
from the
A
annihilator, yes. That's
uh,
why A times X equal to 0.
yeah.
Yes.
So I write ideal, so x times y in A and A times xy, we use associativity equal
Hmm.
to 8 times y equal to 0 times y equal to 0. So
So,
xy in annihilator AI. From this conclude that ni nai times I subset of annihilator. Hence, annihilator is the right ideal of A.
excuse me, where did you use it? I is a right ideal.
I, uh, so işleme kaldı.
Where did you use I is a right ideal? In the
Uh,
proof, in the solution, where did you use it?
okay.
No, no, I
Where
mean,
and
if you consider A, X, Y, okay?
xy.
Here.
Okay. Uh, y in A and x and I.
Mhm.
Uh, x and I and this subset of I because E in A. So x times I this belong to EI.
Okay. Why you need this? Why do you need it? You have to prove
Yeah.
any x, y equal to 0. Yes. For any x from uh, annihilator and any element y from A, from the algebra. You have to show that a x, y equal to 0. The important thing is this one, okay?
I don't understand.
Mana nina idealligini, uning idealligiga hech qattiq
Bununla
foydalanmayapsiz-ku.
idealligi, yine idealligi.
Ini
İni
idealligiga hech
değerli
qattiq
foydalandık. Yo, ma beta foydalandık ki x, y, i'ga tegishligida.
Nima kerak bor sizga buni x, y'ga tegishli?
Yo, o'zi
Why do you
anihilatorni
need that x and y belongs to I?
because annihilator AI is subset of I because for any uh, for any z annihilator. S- So Z in A. This is definition by definition. I'm sorry. Because
Birinchiden
annihilator
i'de
is
yozish kerak, ikkinchidan a'yı
um,
nol bo'lishi kerak. Shunaqami?
shunday.
The first one, these elements from I, and the
And
second condition is A
it I
multiplied to this element equal to zero.
yeah.
That's why you need the I is in right ideal. The first one,
Mm,
xy belongs to I. The second one, axy equal to zero.
yeah.
Okay, okay.
Maybe next page.
Yes, next problem, next page.
Uh, Problem 2. Let I be a minimal right ideal of the algebra A. Show that for any A in big A, either annihilator AI equal to 0 or I equal to annihilator AI. Science problem 1, we know
Means that
that
in the case of I is a minimal, then annihilator is zero
is
or
0 or itself
itself.
0 I.
Yes. Oh, okay.
Uh, Science problem 1, we know that annihilator is a right ideal of A and
Mm,
annihilator subset of I. Uh, we know I is minimal right ideal, so
mm.
annihilator AI equal to 0 or annihilator AI equal to I.
Okay.
Mhm.
Next.
Hmm.
Personal, do you have some questions?
Yes.
So,
I want to ask why from I want to know why minimal right ideal give us any letter AE equal I.
what does it mean, minimal ideal?
Hmm?
Personal, what does it mean, minimal ideal?
Hmm. It's this ideal means that ha there is in every ideal.
No, minimal means there is no
No.
ideal
Mhm.
smaller than I,
Yes.
which is a subset of I. There is no ideal.
Ah,
So, if it's a minimal, there is no sub-ideal of I. But he shows that annihilator is a subset of I, and it is an
I
ideal.
minimal.
It is
Uh,
an ideal.
uh-huh.
This one, annihilator is
Yes.
either zero or either same with I.
Uh-huh.
Okay?
Okay, yes.
Next. What happened, Madhuhan?
I don't know.
Where's the next problem? Third page. Sekira oynadığında Mişken Madhuhan. Bittani ochyapsiz, ochib bo'lmasdan keyin orqaga qaytyapsiz. Orqaga qaytmasdan yana oldinga o'tib ketyapsiz. Sal kattaroq qiling.
Yo, tushunmay qoldim unda qani.
Sal kattaroq qiling bo'ldi. Sure. Next. Okay.
Problem 3. Let I be a non-nilpotent minimal right ideal of A. Algebra A shows that there exists an element A in I such that I equal to AI. Firstly, we will show
So,
that.
stop. Not too quickly. Let I be a non-nilpotent minimal right ideal.
Yeah,
What does it mean nilpotent? Everybody knows, yes?
yeah. We call it I is nilpotent ideal. There exists such that K is natural
Natural
number.
number k such that e
Okay,
on the power k equal to 0.
the uh,
Okay.
K is equal to 0.
So in the case of I is a non-nilpotent minimal right ideal of S, then there exists such
This
element A such that I equal to AI.
Yeah.
Okay. Show it.
Uh,
Prove it.
firstly, we will show that 8 times I right ideal of I for any A in A,
Okay.
because I is right ideal of A. Therefore, I times A subset of I, then AI times I equal to A times IA. This is associativity.
Mm,
This subset of A times I, because this subset of I. Hence,
okay.
AI is right ideal of A. We
Okay.
know that AI subset of I, because I is a right ideal of A.
Mhm.
Yeah, no. I'm sorry, because A is in A.
Uh, you take an element A from the idea, then
Yeah,
AI is a subset of
of
I.
A.
Okay.
When A in A. But for any A of element of algebra, AI is right ideal. This is true. But this AI subset of I is true only A in I.
Mhm.
Uh, then A times I equal to I, or AI equal to 0 for any A in A, because I is minimal
The
right
minimum.
ideal.
Yes. Because of the
If
minimality,
Yeah,
you have the
if
Yes.
AI if AI equal to 0 for L A in A, then E square equal to 0.
It means E
Therefore,
is important.
yeah, E, B, and nil patent. This is contradiction. Hence,
Mm.
there exists A in A such that equal to I.
Okay. So actually, the condition of non-nilpotency can be replaced by the condition of E square is not equal to 0, I think, yes?
Yes.
Because you use only from this condition which is square equal to 0, we obtain the contradiction.
Yeah.
So this non-importancy can be replaced with the condition of E square is non-zero.
Yeah. This is this
Nilpotent,
condition in state E square
yes,
equal
E
to
square is non-zero.
non-zero. Yeah. Maybe E is nilpotent. but e square not equal to 0.
Yeah. Okay. Next.
This problem
Problem 4.
I not solved. I
Hmm?
cannot solve it.
You couldn't.
I cannot
Why?
solve it.
So what is it?
Uh, let I be a non-important minimal right ideal of the algebra A shows that there exists an idempotent element A in I such that I equal to AI.
So
Okay.
in the problem 3, you show that there exists an element. Now
I
you have to
idempotent.
show that there exists an idempotent element. Yes.
Yeah. Yeah.
Such
I
that I
can.
equal to
Yeah. I
EA.
cannot show idempotent.
You
Idempotent element.
you cannot find an important element. Yes.
Yes.
Mm.
We may easily see big A is right ideal of A since
Yes.
previous problem for any A. In particular, A in A is the right ideal of A, so AI subset of I. Then there exists A in A such that AI equal to I because I non-nilpotent minimal right ideal of A.
Mm.
So we find element A in I such that A times I equal to I, but I don't know. We don't know A is idempotent or not.
You
If
couldn't
uh,
find an idempotent element. Yes.
yeah, yes, if I has an idempotent element,
Mm.
if so
Mm.
AI uh, AI is not equal to 0
If agar
because
E'ning ichida bo'lsa-da, to'g'rimi?
yes ha ichida bo'lsa o'zi ichidan
Now,
olyapti ya'ni
actually, you consider associative algebra, yes?
yes
In the associative case, if E is a non-nilpotent, then there exists idempotent element. I think
but
my response showed it, yes? My response?
Ustoz,
Do you prove that associative algebra, non-nilpotent associative algebra, always has an idempotent element?
uh,
no,
kann ich finite dimension or
Finite dimension, okay.
but
yo
this is
mavjudligini ko'rsatmaganman. Bor deb olib isbotlaganman mana.
Kimda ko'rsatuvdi-ku? Sanmi, anaqa, Navro'zboymi?
yo'q uni mavjudligi chekli o'lchamli emasmidi yo'q ixtiyor o'lchamlida ham mavjud bo'laveradimi adashmasam sochiga
Only in
ko'rsatdim
finite dimension cases.
yes fine but this case maybe infinite dimension I am try prove that AB times AB equal to AB not but I cannot prove
Since there is in the problem, there existed independent element, it means that any non-important right ideal should have an important element, or from the minimality you will have this condition. Maybe. Okay. Uh, what do you think? We will leave now this problem or not? Or we will try to solve it?
Lek ancha urindim, chiqmadi nimagadir.
Mother?
Ancha urindim lekin bu masalaga. Chunki 4 bilan 5 ga urindim, ikkalasi ham yetib bormadi oxiriga. Bundan keyingisi ham.
Bundan keyin sen chiqmading. Nechtasi chiqdi o'zi?
Shu ikkalasi keyin 8-sidan bitta holati qolib ketdi.
6-7 nechtasi bor?
Ha, chiqdi. 6-7 dan qildim.
Okay, we will leave it. Now, next problem. Fifth problem. Mm,
This is problem 5. I cannot solve this.
Okay, give it. What is the problem? Formulate it.
Let A be a semi-simple algebra is radical of A equal to 0, and let A be an idempotent of the algebra A. Shows that the right ideal AI is minimal if and only if the algebra AI is a division algebra. Yes, every non-zero element of EAE is invertible. What happens if radical of A?
I maybe uh, you can use the last problem of force assignment. To'rtinchi zadachani oxirgi masalasida shu YAYga oid formula bor edi-da. Keyin JAni NAga tengligini isbotlagandim. O'sha ikkalasidan nimadir ishlatsa bo'ladi, agar foydalanmagan bo'lsangiz.
Yo'q, hali foydalanmadim. Qarab ko'raman-da.
O'sha
To'rtinchini
ikkita
o'zida to'g'rimi?
zadachani ko'rsangiz, men skrinshot qilib tashlayman.
Qarab.
So this problem also is not solved, yes?
Yeah, I not solve it,
So
but
a semi-simple algebra, it means that an important radical of the algebra is equal to 0. And let A be an idempotent element shows that the right ideal EA is minimal if and only if the algebra EAE is a division algebra. What does it mean, division algebra?
in
Oha.
Russian telo.
Hmm?
Cism.
Every non-zero element
Non-zero
is
element.
invertible, yes?
Yes. Ruschasi telo degan ekan, o'zbekchasi jism, keyin inglizchasiga izlab ko'rsam division algebra deb chiqdi.
Division algebra. Hmm. Okay. Next.
Problem 6. Let I ideal of A and K ideal of I show that IKI ideal of A and IKI subset of I. Solution IKI times I equal to IK times IA because associative algebras. This is subset of IKI because 8 times I subset of I because I is ideal. And A times I ki equal to AI times ki. This is A I is two sides ideal, so A times I subset of I. So this this set subset of I ki. So we conclude I ki IKI uh, ideal of I. These two equation. And IKI subset of I. This is easy because I is ideal. So IK subset of I times A subset of I.
So in this problem, ideal means two-sided ideal, yes?
Yes. This is on two sides ideal.
Okay, this last condition, IKI is a subset of I. It's okay. But you may write IKI is a subset of K also.
Uh,
Is it right or not? IKI
you
is a
say
subset of...
this is K?
No, no, no.
No, this K.
Here, yes. IKI is a subset of K also.
This is true because IK is subset of K, KI
Yes.
subset of K, because
Yeah.
K is
Is
two
an
sides
ideal.
ideal I. Yeah.
No, it is interesting. Why you need IKI is a subset of I in this problem? I didn't understand this. What's the
But
point here?
but in lekin ruschasidan shunaqa edi.
Okay, maybe in the next problem you will use this one. Okay, next.
Problem 7. Let I two sides ideal of A. Prove that Ri equal to such that A in I such that I times A equal to 0. This is two sides ideal I, and Li equal to A in I such that A times I equal to 0. These two sides ideal of A.
May I ask something? Is Ri or Li similar with annihilator of AI? I think it's similar, yes.
No. Yes, similar, but unrelated to AI.
Hmm.
uh, hozir o'zi
Farqi bormi?
ya'ni
Bir xil
ini
yo'qsa
ichidan yo'q,
What is the difference
farqi bor.
from the Li and from the annihilator of
Hozir
I?
Aha.
o'zbekchasi aytganda, masalan, bu yerda A ni shunaqa A'larni topyapmizki, I bilan A'ni ko'paytmasi 0 bo'lsin deyturdik. Nariginda A'ga sherik topayturdik, I ni ichidan ko'paytmasi 0 bo'ladiganlarini
Ha,
ajratib
unda A fiksirlangandi. Tushundim.
unda A fiks qilingandi. Bu yerda I ni hamma element bilan ko'paytmasi 0 bo'lishi kerak.
Tushundim.
Nariyoqda A ni sheriklarini olgandik.
Hmm. Aha.
Solution Ri equal to this set. We will see these products.
Mm.
We will see these products. Ri times I. This is equal to span of x times I, x in Ri and y in A. We know that Ri times I subset of I times I, because Ri subset of I. by definition. So Ri times I subset of I A, this is subset of I because I two sides ideal. Hence x y in A. First condition this x y in A. Since x in Ri, then we can write I times x equal to 0. Therefore, times xy equal to ix times y. This is equal to 0 times y. This is equal to 0. Hence, xy in Ri because e times xy equal to 0. And xy in I is Ri times I subset of Ri. Then we will this product A times Ri equal to span of y times x. This is x in Ri and y in A. No. Y times x in I from I is two sides ideal. And I times yx equal to I times y times x. I times y, this is subset of I. So this is subset of I times x equal to 0. Then I times yx equal to 0. Then y times x in Ri. So A times Ri subset of Ri. We conclude that Ri two sides ideal of A. We may show that similarly Li two sides ideal of A.
Okay. Everything is clear for everybody? Why Ri is a two-sided idea? Ursana,
Yes, yes,
did you
it's clear.
understand?
Yes, it's understandable.
Akbar,
Yes.
huh? Did you understand?
Yes.
Ne yapıyorlar? Bu için bilin. Ne bakın? Actually, there is two important things. This one and this one. It means you
Okay.
have to show x, y also belongs to Li and yx also belongs to
Ri.
Li.
Yeah.
For this purpose, you consider ixy and iyx. And in both cases, you show that this product is equal to are equal to 0. That's all. Okay?
Nimaga ovoz uzilib kelib qoldi? Tushunmay qoldim.
Did you hear me? Hocam?
Yes, yes. Yes, we heard.
Okay.
Yes,
Okay, next.
boyagida ye qolib ketdi idempotent. We didn't show ye idempotent element. For problem
Topolmadim.
The
3, yes?
problem 4,
Problem
yes?
4.
4
Yes.
and 5.
Maybe in the end, Azamat will prove this, will solve this problem, yes?
Okay,
Azamat?
yes.
Yeah. I used AI and sent the solution to the chat.
Yeah,
Okay.
after the last problem, you will
Okay.
show it, okay?
Okay.
Okay.
So now
Pro-
let's continue.
Problem 8. Let I be a minimal ideal of a finite dimensional algebra A. Show that either I square equal to 0 or I is a simple algebra. We know that I square is a
So
ideal.
E is a now So is a E is a minimal ideal, not a finite dimension algebra, and in this case you have to show that either E square equal to 0 or
Or
I is a
I is a
simple.
simple
Now
algebra.
what
Yeah.
does it mean I is a simple? So
Uh,
I
this is
don't
not.
don't have the ideal, yes? Sub-ideal.
Yes. Yes.
There is no
I.
sub-ideal of E. I.
Yes.
Is it is it similar
Proper
with
sub.
minimality?
No. No.
Si
Minimal ideal is uh, there is no ideal of A. This
uh-huh.
case, there is no ideal of I.
Yeah.
Proper
Ah,
sub-ideal.
in
There's a
second
difference.
case, only in I we
Yeah,
must
Yeah.
consider.
yeah.
I understand.
Uh, Solution, we know that I square is a ideal of A and I square subset of I. Uh, I is a minimal ideal, so I square equal to 0 or I square equal to I. First case, this is in problem. So assume that I square equal to I
Mhm.
and chi be an ideal of I. Then ki ideal of I in
Mhm.
uh, previous problems,
The
problem
previous one,
6,
yes.
and iki subset of I.
Here you will use this
Yeah, yeah,
condition, this property.
yeah. So I is minimal ideal. So
Mm.
I equal to I or ik equal to 0. First case, iki equal to I. We know that iki subset of chi uh,
Which I
because chi is
mentioned
ideal,
before.
and, and chi is subset of I because chi be an ideal of I.
Mm.
So we know that iki equal to I, so chi k equal to I. The second case, iki equal to 0, but I not finished this case.
The second case, yes.
Yes, I think
If I
find
k
the
I equal to 0,
yeah, I think find dimensional algebra, find dimensional where uses maybe
so what does it mean?
maybe
I
basis.
square is equal to I and k is an ideal of I.
Yeah,
aka is an ideal, aka is a subset of Y, so aka is I or 0. This case, if ik is equal to I, then we know that ika.
maybe basis of k is finite, but mm, mm, so I think we this is if iki equal to 0, then chi equal to 0, I think, but I don't hold this.
Called ya ideal boson.
Bu yerda o'sha cheklilikdan foydalanish kerak. Men foydalanaman deb buni yoyib ham ko'rdim, lekin hech keltirib bo'lmadim. Endi masalan, kana ixtiyoriy bazasi uchun olsak, i desak, o'shani o'ng tomondan ham i'ga, chap tomondan ham i'ga ko'paytirganimiz 0 bo'lishga majbur bo'ladi. Umuman olganda ixtiyoriy element uchun. Lekin baribir hech Hmm. Bunda mana bazisi nolga kelib chiqmayapti-da hech. Ah, we have idempotent element if find dimension. No. Idempotent element K deb yozishyapti emas-ku. Demoqchiman masalan, K ning elementi I ning ham elementi bo'ladi-ku. O'sha idempotent element olsak, Y ning kubi teng 0 bo'ladi-da, Y teng 0 bo'lib qolyapti. Masalan, hozir. Boya aytdik-ku, idempotent elementi bor deb I ni.
Hmm.
Agar o'sha idempotent element K deb yotsa, K teng 0 ga kelib chiqib qoladi.
Yeah, but mana equivalent is equal to I, okay? It
Yes.
means equivalent is non-zero.
Yes.
In the first and second problems, so what did you show? For example, in the first one, could you open the first problem?
Birinchi
Birinchi,
mas.
ikkinchi problem.
Okay.
First and second problems. Birinchi, ikkinchilar olishim. No, second. Next. And the third and first problem.
Yeah.
Yeah, in this problem, especially. In this case, is non-important, minimal idea,
Yeah.
shows that there exists idempotent such that E equal to EA. If you
Yeah.
prove this one, maybe you have to use this problem. Maybe,
Yes,
I don't
yes.
know.
But demoqchi bo'lganim ham mana shunaqa
The last
hozir
one.
kelib qoldi. Masalan, Y I dan topiladi dedi-ku, lekin K dan topilishi ham kerak edi. Agar K dan topilganda bu o'sha bizning masalamizda K dan topilganda masala hal bo'ladi.
Hmm.
Lekin bu yerda I dan topiladi deyapti-da.
I'dan topilsa unda boyaga I, K, I 0 bo'lmaydi.
Okay.
Nega? K da I yotmasa bo'ldi-ku, K da topilsa 0
Idempotent
bo'lmaydi.
elementni K'ni elementi ko'paytirgan idempotent element ko'paysa nol qolishi mumkin. Muayyan.
K ni ichidan chiqib
K ham
qolsa
bizda I'ni qismi, to'g'rimi?
O
shunday.
I'da Y bor edi.
K da
Y
bo'lmaydi.
K nimani beradi yani? K'ni beradi. Bu tomondan Y'ga ko'paytsa, xususan ham I'ning ichida Y degan element bor.
To'g'ri.
ya nega YK K'ni beradi?
Mana Y idempotent element I'niki. I u birlik element ham bo'ladi.
Ya
Nimaga?
nega birlik element bo'ladi?
O'zi idempotentligini ko'rsatarligi birligi ham kelib chiqar ekan. Aynan mana shu element idempotent element bo'lib qolar ekan. Idempotent element bo'lsa u birlik.
Nega birlik bo'lishi kelib chiqadi?
Agar uzr birlik bo'lsa Y A teng I bo'ladi.
Unda bo'lmaydi-da u. Birlik bo'lmaydi-da.
Yo, I'da birlik bo'lib qoladi demoqchiman. Yo, I'da ham bo'lmasmikin?
Bilmadim. Okay. So you couldn't finish the last problem also, yes?
Yes.
Okay, what about the first problem, Azamat? Could you show and explain now the solution of this problem?
Yeah, if Nabuhan can open the picture in the chat, we will discuss.
Okay.
Yeah, you
Can
may share, and Navahan will stop the sharing. Navahan, please stop the sharing.
Azamat akaniki?
Yo'q, o'zingni anaqani o'chir, sheringni stop qil.
Ha, bo'ldi, bo'ldi.
Azamat o'zi qo'yib o'zi gapiradi. Azamat?
Bo'ldi, bo'ldi.
Okay. So I got this solution from DeepSeek, and we already know that AI is equal to I, right? So we will not
Yeah, in
discuss
the
the
third
part
problem,
about.
we showed it. Yes, okay.
Yeah. So if AI is equal to I, then there, since A is taken from I, so there exists such E from I that AE is equal to A, right?
Yes, yes. Correct.
So if we consider this product, it's A squared minus AE. Then from associativity, we can change the bracket, and finally we get 0.
Because of
Uh,
E, AE equal to A. Yes?
yes, yes,
Okay.
that's why.
So
So
here,
here,
this one equal to A.
yes, A.
Okay. So,
Thus we conclude that E squared minus E belongs to this set, and
belongs to
this
the
set,
set. Yes.
yes, and this set is right ideal contained in I.
It is
If
right
it equals
ideal
to,
and belongs to I.
yes,
Okay?
and if it equals to I, if this set is equal to I, then it means that AI is equal to 0.
Yes.
This is a
Contradiction.
contradiction because, yeah, because
So,
AI is equal to I. So it is a proper right ideal. So it must be 0 by minimality
because
I.
of E is the minimal
Yes.
ideal.
Uh, yes, that's why. And now from this we get that E squared minus E is equal to 0. This means that E is idempotent.
So this set is contains only
Only
0
0.
element.
Yeah.
That's why
Yes.
E square minus E equal to 0.
Yes.
Mm. Then,
Then, since E is taken from I and it is not equal to 0, EA is a non-zero right ideal contained in I. So EA must be equal to I.
the last one, could you repeat the last explanation from here?
From since, right? Okay.
Yes.
So this idempotent element E belongs to I, and it
Mm.
is not equal to 0.
Okay.
So EA is a non-zero right ideal contained in I
Why?
because because E is from I. E
Mm.
is the element of the ideal,
Yeah,
but I
contained
is
in I. Okay. Why it is that ideal? EA. Yeah, from the associativity, EXY equal to EXY, yes?
yeah
Yeah, you may write E equals. And y, it is just equal to, you may continue from the associativity, EXY. It means that if you take an element E equals from this set and any Y from the A, EXA again belongs to the set EA. The set belongs to the EA.
Yes.
Belongs EA. Okay, EA is an ideal and it is subset of I.
Yeah. But
Since
I
it is
is
minimal,
minimal.
uh,
That's why it must be equal to I.
must be equal to I. Okay, good. Any questions by this problem?
No.
You got that?
Sampai Ustaz. Assalamualaikum.
Waalaikumsalam.
Bo'ladi.
Hamma masalani tushundingizmi?
Endi ayrimlarga yozgan tushundim.
Okay, Navhan, that's all?
What?
The last proof is general proof
Uh,
about existence of idempotent element in associative algebras. Yes.
But I use minimal idea.
yeah, you will use some conditions. I don't know for the any
Minimal
association,
ideal condition. Yes.
for the any non-important algebra, it proved little bit differently, I think.
But in general, there exists this kind of result that in any associative algebra exists idempotent element.
Non-nilpotent associative algebra.
For non-nilpotent. Thank
Now,
you.
Navhan says that finite dimension non-nilpotent. I'm not dimensional. Maybe yes, finite dimensional.
Thank you. I understand.
Okay. Any other questions or comments? Yes, вопросы, комментарии.
In here, the definition of semi-simple associative algebra means GA is equal to 0. Is it?
Yes.
I understand. Thank you.
Ну, наверное, в следующий раз можно 2 занятия попробовать запланировать.
Да,
Если
если
будет
так
понятно.
быстро будет, да.
Кто в следующий раз по плану у нас?